Welcome back to Aurora Tech Channel. Today, I will review the Elegoo Neptune 4 Max, which is based on the Neptune 3 Max, but has a lot of upgrades. It's currently the most affordable large-scale printer in the market, priced at $470. So, let's take a look at what we can get from it. The print volume is 420 by 420 by 480, and the motion system uses palm wheels on the X, Y, and Z axis. The Y-axis uses two 20 by 40 extrusions to form a wider base to support the bed with 6 palm wheels. The Z-axis uses dual stepper motors and dual lead screws with a timing belt. As the gantry is much taller than a regular bed slinger, it has 2 metal rods to support the frame. The extruder is a 5.2-to-1 dual gear, and the hot end is high flow with a ceramic heat core similar to the Bamboo Lab X1 series. The maximum nozzle temperature is 300 degrees Celsius. There's an accelerometer inside the print head for input shaper calibration. It uses an inductive sensor for auto bed leveling. There are dual 40-15 part cooling fans on the print head and an auxiliary fan with dual 60-25 fans at the back of the gantry. The print bed has 6 leveling knobs and insulating foam to better retain the temperature. The maximum bed temperature is only 85 degrees Celsius, and the print surface is a textured PEI spring steel sheet. It uses an MKS Pi motherboard with a quad-core 1.5 GHz processor to run Klipper firmware. It has 1 GB of RAM and 8 GB eMMC onboard storage. The stepper drivers are TMC2209 stylet drivers that support sensorless homing. The PSU is 400 watts, the screen is a 4.3-inch touchscreen, and it supports network printing using the Moonraker API over your local Wi-Fi or Ethernet network. It also supports USB drives if you prefer printing completely offline. For other features, it has a drawer, filament runout sensor, belt tensioners on both the X and Y axis, an LED light strip at the top of the gantry, and another LED light at the print head. Compared to the Neptune 3 Max, with all these upgrades for just $40 more, this machine looks pretty attractive. I would like to thank Elegoo for sending me the machine to review and for sponsoring today's video. And with that, let's get started. The machine comes in one box, and all parts are protected by laser-cut foam. Besides the standard components of a bed slinger, including the base, the gantry, print head, filament holder, and the screen, we also have an auxiliary fan mounted at the back of the gantry to provide extra cooling. There are also 2 metal rods to support this machine's tall frame. Once the machine is turned on, you will see the same screen as the other Neptune series. As this machine supports Wi-Fi, I will connect to the Wi-Fi network first. Just select the SSID and enter your password. Once an IP address shows up here, it's connected to your network. This machine doesn't have auto-Z offset, so we still have to do the traditional paper test to set the nozzle height and manually adjust the leveling knobs underneath the bed before doing auto bed leveling. An 121-point probe is a little overkill, but as we won't do this too often anyways, I will just let it finish. It took around 7 minutes. Then I will calibrate the input shaper, starting with the X-axis, then the Y-axis, and after another 6 to 7 minutes, it's going to save the value and restart the machine. We can load some filament and start our first print. I will start with a 26-minute sample Benchy G-code file that came with the machine. It seems the first layer is printing very aggressively, especially for a huge bed slinger. I will let it print a few layers and allow the machine to print at its top speed. Then I will check the sound level. The sound meter is placed 6 inches away, and the sound level is in the low 60s. The loudest sound is from the auxiliary fan, so no matter if the print head or bed is moving fast or slow, the machine just stays in the same low 60s. The print finishes in 28 minutes. It doesn't look too bad. The surface is clean, there isn't much ringing and ghosting, and the layers aren't perfect, but aren't too bad for a huge bed slinger printing at this speed. I will print another one using a normal 0.2mm layer height. Since this printer only came with the skin Cura, and I normally won't use Cura anymore, I will just make it a PrusaSlicer profile. I will set the print speed to 200mm per second, and the external wall, bridges, and first layer will slow down accordingly. For the extruder, I will set the retraction length to 2mm and the retraction speed to 40mm per second. These are just my typical Klipper bed slinger settings, which work pretty well on most machines. For PLA, I will set the nozzle temperature to 225 degrees Celsius and the bed to 65 degrees. I will create one profile with the 15mm cube per second volumetric speed and another one at 25mm cube per second if I need to print something bigger or faster. For the machine limit, I will set the x-axis acceleration to 8K and the y-axis to 4K. As I already entered the IP address of the printer and added it as a physical printer, I will just send the print over the network. I will use Sunlu Purple PLA and VOXELPLA Pro to print 2 more Benchys with the same G-code and compare the result with the sample G-code. I think when printing at a 0.2mm layer height, the quality is much closer to a normal Benchy. The surface is clean and the cooling is good. So I would rather take 6 more minutes to print a 0.2mm layer Benchy using PrusaSlicer instead of using 28 minutes for a 0.25mm layer sample Benchy. Next, I will do a clearance test by printing the number slider. It seems the first few layers are good as I can clearly see gaps between the tiles. The print finishes in 2 hours and 48 minutes. The top surface looks good, even though this model generally has some stringing on the top. The bottom is also good, so let's try the clearance. All tiles can move smoothly. Then, I will do a retraction test and print my own design, the Honeycomb box. This tiny bit of retraction requires the extruder to print a drop of filament, retract it immediately, and move to the next spot. For many extruders, this can result in stringing and even broken patterns. The print finished in 1 hour and 49 minutes. The patterns are clear, and all of them were printed successfully with no stringing at all. Let's do a comparison to other machines that printed the same model with relatively good results. I think the extruder of the Neptune 4 Max is above average and actually one of the best in terms of retraction. After that, I will try a decorative print, the Robo Alpaka from Prusa. The print finishes in a little less than 5 hours, which is a bit slower than the average 4.5-hour new generation print speed, but it's still not the slowest. Let's do comparisons. It's better than the Congo T500 in terms of print speed and print quality, as the T500 is an even larger bed slinger with a 500mm cube print volume. When compared to the standard size CR10SE that I reviewed last week, the print speed of the Neptune 4 is faster, but the CR10SE is slightly better. Compared to the K1, the print speed and print quality are both similar. They both have some ringing on the surface, but it shows up in different areas. When compared to the Prusa MK4, the MK4 is better, but the time is also the slowest of all new generation printers, as it is still running its own Marlin variant firmware instead of Klipper. Then, I'm going to print a huge 480mm tall trash can to max out the Z height. When using vase mode, it's going to take less than 10 hours, but the problem is it would probably be unusable as the 0.4mm wall will just break if you actually use it or even grab it too hard. If a 0.8 or 1mm nozzle was available, we could just swap the nozzle and print it with vase mode to get a thicker wall. But as this printer only comes with a 0.4mm nozzle, I will just uncheck vase mode and manually set it to print 4 bottoms, 0 top, 3 walls, and 0% infill. It's going to print a trash can with a 1.2mm thick wall. The layer height is set to 0.35mm. Normally, I would just set it to 0.32, but I have had some successful prints even with a 0.4 layer height. So let's see if this works on the trash can model as well. The first layer looks pretty good, but the lower right is actually a bit too high. I just manually adjusted the knob, but it is still usable. The print finishes in a little less than 23 hours. The first 4 levels of the bottom look really good, but when the trash can is taller, the momentum of the bed shows up on the surface. When you look at the top level, the surface quality is much worse than the bottom. It's easier to see by putting them side by side. The bottom of the print looks good. These are the areas where the nozzle is a bit too far, but it didn't cause any issues. For a print of this size, imperfections on the surface may not be very noticeable. It could be improved by using a larger diameter nozzle. This would increase the volume of filament extrusion while reducing the print speed to match the maximum volumetric speed. Next, I will do an accuracy test going from 0.05 all the way to 0.2, and I will try to put the cylinder and square inside the other object. Let's see how these parts fit with each other. The cylinder is accurate, and the cube is also pretty accurate. These overshot corners don't seem too bad. Let's see how good the clearance is. I will start with the cube. It can clear from 0.225 all the way to 0.1. For 0.075 and 0.05, they're a bit tight, so I would say the clearance can go up to 0.1 millimeters for the cube. For the cylinder, it clears all the way from 0.225 to 0.05. It seems when printing a cylinder without the overshot corner, the clearance can go as tight as 0.05 millimeters. Next, I will try some different materials starting with PETG. I will use a 0.3mm layer height and print a scaled up version of the tire pen holder. I set the volumetric speed of PETG to 14 mm3 per second, so it will limit the actual print speed to around 116 mm per second, as PETG just can't print as fast as PLA or ABS. The print finishes in 9 hours and 18 minutes. The line between each tire is now printed in the air, but when I print the model at the original size and at a 0.2 mm layer height, it is just supported by the previous layer. Then, I will try to print a TPU wallet. When printing TPU, as well as other materials that don't require much cooling, the back auxiliary fan can be manually turned off. I will measure the sound level without the auxiliary fan. It stays in the low 50s, which is around 12 to 15 decibels quieter than using the auxiliary fan. The extrusion of this TPU wallet is excellent, and I can't see any issues with it. As the maximum bed temperature of this machine is only 85 degrees Celsius, even though the nozzle can reach up to 300 degrees Celsius, you may still be unable to print filaments that require an 100 degrees Celsius or higher temperature heated bed. So, I would try to print a snap hook with nylon. All my nylon filaments are stored in this Sunlu 4-spool dryer, which has a storage mode that will heat up the machine when the humidity inside is over 50%. Currently, it's 35%, which is okay for other filaments, but still a bit high for nylon. But I will just print it without any extra heating and see what result we can get. I set the print speed to 100 milliliters per second, and this snap hook finished in just 32 minutes. The result is not too bad, but the nylon isn't completely dry, and there's quite a lot of stringing. The layers are okay. There are no blobs, but I still want to dry the nylon for around 2 hours and reprint the model. After drying it for a little over 2 hours, I restarted the print. This time there's much less stringing, so the result is better, but I think the nylon may still need to dry even more to get a perfect result. However, these hooks are functional. Finally, I will try to print some ABS. An open frame machine with just an 85 degrees Celsius heated bed is far from ideal for printing ABS, but I still want to try. I will print the same ABS crate and apply more glue to the bed. The corner still warped a little, but as I applied a thick layer of glue, it prevented it from lifting too much. However, there is layer cracking in the same area, just like most other open frame printers, as the ambient temperature made the ABS cool down too quickly. The pattern was printed nicely on this Neptune 4 Max. There's zero stringing, and despite the slight warping, the bottom actually printed pretty well. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The max Z height is 480 millimeters, and it's supported by 2 extra metal rods. Even though the frame is tall, it stays pretty rigid. The overall build quality of this machine is solid and is consistent with the previous Elegoo Neptune 3 series. 2. The 5.2:1 ratio dual gear extruder works very well. It successfully completed the Honeycomb box retraction test and printed the ABS crate with almost no stringing, outperforming most machines I've tested so far. 3. The print speed is fast, with the x-axis acceleration set to 8K and the y-axis to 4K. For regular size models, there are no noticeable print quality issues. However, challenges arise with larger models like the trash can, where maximizing the Z height with a 0.4mm nozzle at a high speed is not ideal. In decorative prints, the print quality is better than another $800 large 3D printer I tested, the Congro T500, and this is also comparable to the CR10SE. It excels in accuracy tests, achieving an above-average clearance as tight as 0.1mm for the cube and 0.05mm for the cylinder. 4. It uses stock Klipper, the Moonraker API, and the Fluid Web interface without unnecessary modifications. The network printing can be done within your local network, eliminating the need to send your files to the cloud. The Wi-Fi feature is also compatible with any slicer. 5. The part cooling is robust. The printhead features dual 40-15 part cooling fans, which are enough for prints that don't require an excessive amount of cooling. Additionally, the dual 60-25 auxiliary fans at the back provide super strong cooling, so I can feel the airflow from 2 to 3 feet away. Now for the cons. 1. The motion system uses palm wheels on all axes. I believe it's acceptable for the Z-axis, but for the X and Y axes, which require rapid movements during fast printing, palm wheels wear out much faster compared to when they're used on a regular speed Barlin printer. 2. While using the manual leveling knobs under the bed and using paper to set the Z offset still works, as a new generation printer, I would prefer to have an auto Z offset feature to eliminate the need for leveling knobs and having to use a paper to set the nozzle height. 3. The PSU is a 400-watt unit, and it takes too long to heat up the bed. It took 7 minutes to go from a 25 degrees Celsius room temperature to 60 degrees Celsius. If it's required to heat up to the maximum of 85 degrees Celsius, it took over 15 minutes, which is much longer than average. 4. The screen UI can only access files on the USB drive. It can't access G-code files uploaded via Wi-Fi or stored on the eMMC. The screen is from the previous generation of Elegoo machines and functions more like a G-code sender, similar to the Cheedy Klipper series. They both use the same type of screen with the same MKS Pi motherboard. However, this combination doesn't communicate well enough with Klipper. For example, during input shaper calibration, the screen froze for a few minutes without displaying any progress or data, even though the data was available from Klipper. 5. Currently, there are no available large diameter nozzles. I would expect that when a large printer like this is released, matching larger diameter nozzles should be available too. The only reason you would get a printer of this size is to print big. However, as of now, the Klipper firmware only calibrates one set of input shaper values at the lower part of the gantry. The movements of a bed slinger can have varying impacts as the Z height increases, so the data calibrated at the bottom may not work best for the top. Currently, the only workaround for a tall bed slinger is to use a larger diameter nozzle, allowing for more melted filament and a slower printing speed to compensate. This approach still achieves a faster overall print time, so I would recommend that Elegoo prioritize making these larger diameter nozzles available as soon as possible. In conclusion, this is the most affordable large-scale bed slinger in the market. There is no other machine with the same print volume available for under $500. It's based on the $430 Neptune 3 Max, but has been upgraded with a faster motherboard that runs Klipper firmware, a stronger extruder, high-flow hot end, a powerful auxiliary fan, and other features like network printing and sensorless homing. All these upgrades cost just $40 more than the Neptune 3 Max. Despite the maximum nozzle temperature being increased from 260 to 300 degrees Celsius, the maximum bed temperature has been decreased from 100 degrees Celsius to 85 degrees Celsius due to the less powerful 400-watt power supply instead of the 500-watt one on the Neptune 3 Max. The maximum Z height has also been decreased slightly by 20 millimeters. The size of the machine and this hardware justifies the price, and the build is solid, while the print quality is still fairly decent. But to keep the machine's price low, Elegoo has opted for palm wheels for this fast and large bed slinger, which may be a drawback when compared to using linear rails, rods, and steel wheels. I believe Elegoo should take the same approach as the Neptune 4 Pro and charge a bit more to use steel wheels. Nevertheless, the Neptune 4 Max remains the most budget-friendly large-scale 3D printer currently available. So if you're interested, I put the link in the description. That's it for this video. If you found it helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time. Now for the cons. Now for the cons. 1. The motion